today, nonlinear systems of equations. This will be today and Monday, and then next week you'll have another quiz and a chapter test, and we'll move on. Okay? So a system, remember a system has, when you have two equations, or two or more equations, in this case you're going to have two, and when you're doing nonlinear systems, one of those two equations cannot be linear. Tell your neighbor how you know something is linear.
X increases.
Okay, I heard some of you say like straight line. Okay. Jonathan said X and Y both have the same increase by the same amount. It's a constant. It's in the form y equals mx plus b. Okay, so that's linear. This one, the other one we're going to have is quadratic. We know it's quadratic because it has the x to the second power, and it's a parabola. So that one has a parabola. This one's straight line in some way. Okay, so that's what you're going to be doing here. So what I want you to do is, on number 1 here, I want you to graph these two equations on the same graph and find where they cross. Now, if you're using your calculator, make sure you put the accurate points down using your table feature. If you're graphing by hand, that's great as well. But get them on there. Get that picture on your paper. Be accurate about it, otherwise it won't work. So remember, if you're doing this on a calculator and you want to make sure you're at the same starting spot every time, you can always clear your memory. Many of you are very, very good with the calculator, so you don't have to worry about that. But if you're always wanting to make sure at the same spot, second plus 7, 1, 2 clears that memory, so that when you go to your y equals, everything's turned off except for the graph. If I'm going to put in x plus 2, remember, here's my variable key, plus 2. And then x squared, there's x squared plus 2x. If we hit graph, you'll see the picture show up. And you'll note that in this picture, these two graphs intersect how many times? They intersect twice. Now, if I'm actually putting this on a grid, then when I go to my table, so second graph, and I go to the table feature, notice up here it says x, y1, and y2. So when I'm back at my y equals menu, this first graph, the x plus 2, is my y1. This one's y2. Y sub 1, y sub 2. So if I'm graphing linear, I'm hoping you didn't need your calculator for that, but y equals mx plus b, if I'm plotting these points, just showing you how you use your table on here, you'd have, see if I can get that up there so you can see it. Cool. So you have 0, 2, and 1, 3, and 2, 4, and 3, 5, 4, 6, and so on. So you're just following along right here. Okay, and you can kind of go backwards. Get these in here as well. But once you've got them, draw your straight line. It's always good to label it. That's y1. So we'd want to call this one y1 as well. It's a quicker way to label it. Okay, and then if I'm graphing that second one, which we're calling y2, and looking at this, you'd have to go from like -4, 8. That's one of your points. So you're going your x's and your y2 now. So -4 and 8 brings us up here. And then we'd have -3 and 3. And -2, 0. Notice that's a place where they both intersect, so that's one of our solutions, because they both cross right there. Okay, -1, 1, and 0, -1, -1, excuse me, and 0, 0, and then it crosses again right there, and then we're back right up there. So this one goes down, cuts through, and bounces right back up. Alright, so our solutions are whether the two graphs cross. So what are those coordinates? Go ahead and write them down on your paper there. Yeah. Okay, this one is negative 2, 0. And this one is 1, 3. All right. Now, if I just ignore the graph for a minute, because we know what it looks like graphically, what do those points, negative 2, 0, and 1, 3 mean with these two equations? Tell your neighbor there. Talk about it. Anyone want to volunteer there? What does it mean? No brave souls. Yes.
It's probably wrong, but you put the coordinates back into the equation to solve the equation and see if it's right.
Yeah, if you put the coordinates back in and solve it, it's a way to check it, right? It means that this would be a solution. If I put negative 2 in for x and 0 in for y to both of these, they should be true statements. So this would be negative 2 plus 2 is 0. It worked for that one. If I put it in here, negative 2 squared is 4 plus 2 times negative 2 is negative 4. 4 and negative 4 is 0. So that's a solution. If I do the same thing, everyone right now test 1, 3. Make sure it works in both of them. Did it work? Yeah. Yeah, 1 plus 2 is 3, and 1 squared, which is 1, plus 2 times 1, which is 2, is 3. All right. So we now have a picture. We know how it relates linear, in an equation. I want you to take a look at the bottom page, 301, and then your book's kind of set up different. So you have 301 there. Here are the pictures for page 302. What I want you to do is I want you to match the graphs on page 3 or the systems on page 301 with the pictures on page 302. Okay, and then list their solutions. All right, you may have to go back and forth a bit there. Go ahead and work together on that. See how you're doing on it. I'll try to get them both up here so you can kind of reference them. There you go. Next minute, please wrap it up. Okay, this one matches with graph A. Now, I know some of you just put them on your graphing calculator and saw what pictures match up. Remember, this has a y-intercept of negative 2, meaning it either has to be this one right here, or this one right here, or I guess that one right there. Okay, however, this has a negative slope, and that's the only graph that has a negative slope. That goes with graph A. This one goes with graph
C.
This one is graph C. Which means this one right here is graph D. Okay? This one has your y-intercept of negative 1, which is right there for linear. That is graph D. Okay, the way to distinguish between these two, anyone figure that out?
D has a negative 6 and the graph has a negative.
Yeah, that has a negative 6 y-intercept. This one has a positive 2 y-intercept. That makes D go with D because there's negative 6. And that B goes with this one because there's our positive 2 y-intercept. So the y-intercepts will help guide your way a bit. Okay? All right. Go ahead and answer question 3. How can you make a system of two equations when one is linear? How can you solve it? Excuse me. When one is linear and one is quadratic. Go ahead and give yourself a note. Okay, if we look back at exploration 1, what was the first thing we did? We graphed it. So how could you find the solutions? Well, you could graph them and then find the points of intersection. Yep. Yeah, graph them, find the points of intersection, and then make sure those coordinates work by plugging them back in. Hold on. All right. Hey, I want you to go ahead and take a look at, just skip page 303. It's a lot of room for you to take notes, so you can do that later, and you can do some definitions if you want. But page 304. Page 304. Kai will sing it for us. Yeah, Kai. You're the man. All right. You're that guy, Kai. You're that guy. You know the guy that sings. Okay, I want everyone to try number 1, please. Give number, actually do number 1 and 4 right now. 1 and 4. Woohoo. As you're going through these, you may start finding out that as you're graphing them, some of the, like the vertex on them, kind of tough. Like it's not a perfect number on either of those. Okay? So, if you're putting them into your graphing calculator, oops, man, that's ridiculous. You start checking them out, and you see that vertex like dips down way down there. Okay? And you go to your table and you're trying to find the vertex. Notice the vertex is, it's that mirror, that place where your points start to mirror. So your vertex is somewhere between -3 and -2 on the x-axis. Okay? So as you sketch that in there, you can go, well, I know that -2, -3, it's got to be like right in here somewhere. Okay, and I know that that just happens to be your axis of symmetry there. Okay, so it's on that line somewhere there. Okay, and since this is -2, 0 and -3, 0, that's that point and that point. And then you go -4, 2 and -1, 2. Okay, and you keep going there. Your vertex ends up being down there somewhere. Remember, how could you find the y value of your vertex? Remember yesterday with our graphs? We could calculate. What are we calculating on that? If we're trying to find the bottom of our graph. No. Look, yeah, that's a minimum, right? Second, trace, calculate our minimum. So if we actually want to know, you've got to make sure that you're on the correct graph here. Notice when I move my cursor around, it switches my graph. I want to be on the x squared plus 5x plus 6. So if I'm calculating the minimum, it's asking left bound, so I need to go to the left of it and hit enter. And then I need to go to the right of it because it asks right bound and hit enter. And then I need to get as close as I can to it and hit enter. It says, hey, it's about 2.499, which is about -2.5 and -1/4. So that means it's -2.5, 2.5, and -1/4, about right there. You're graphing that. Total one. Our other point was there and there that they gave us, and we can sketch that in. Then we have our quadratic. Our linear should be a lot easier. If we're just doing -x plus 1, y-intercept, that's our b. Okay, so y equals mx plus b. M is -1. B is 1. So that's our y-intercept is b. And it's falling from left to right, so we go down 1/1. Looks like it crosses there and it crosses there. Okay. Drawing our line. Looks like our solution is at -1, 2. Make sure you label your solutions. And 5, 6, -5, 6. Okay, and then you can always test them out there. Check them. Are there questions on that? Okay, I need everyone to plug number 4 into their calculator. So get to the same point I am, whether you're done with it or not, or you're done with the other one. Everyone plug number 4 into your calculator. Okay? Make sure that the negative symbol you use for the -3 is this one right here, not the minus sign. Okay? Otherwise you'll get an error. We're going to hit graph. Show your neighbor the picture you have. Make sure it matches theirs. And make sure it matches mine. Okay. If you need help, hold your calculator in your hand. If you don't need help, put your calculator on your desk in front of you, please, so I can see. Jonathan, you got it? Still plugging it in?
Yeah, mine looks good.
Okay. Go ahead and set your calculator down. Gunnar, you got it? Okay. Hey, you're going to want to write down these keystrokes. Second, trace, which is calculate, right? When we hit second, it's actually giving us this feature. We're going to calculate our intersections, yeah. We want to know where these graphs intersect.
Oh, look at it.
So option number 5. Now, you have to read what the screen's asking you, otherwise it doesn't work. What do you want your first curve to be? Now, the reality is, you don't do this right here, what I'm about to do. The reality is, if in your y equals menu you only have 2 things, it doesn't matter what, you can just hit enter there. Okay? So, once again, if I'm here, it says, what do you want your first curve to be? If you only have 2 things in there, just hit enter. Okay? And then it'll say second curve. Do you want it to be that? And you're like, sure, enter. And now it's saying guess. They're not trying to play a guessing game with you. It's not like the calculator's having fun. Okay? It's wanting you to go as close to the point of intersection as you can for the point of intersection that you want to calculate. There are 2 points. So if you want this one up here, you want to move your cursor as close to that one as you can. If you want this one down here, you want to move your cursor as close to that one as you can. Note that these numbers are changing. That is not the answer until you hit enter. The point of intersection for that top point is 1/3. What's this? Is a fraction. 2/3. 1/3, 2/3. Okay? So, if I'm allowing you to use a graphing calculator here, it's just 1/3, 2/3. Am I allowing you? Yeah, I am allowing you.
Yay.
Okay? It's 1/3, 2/3. Okay, I want everyone to find that other point of intersection, please. Using your graphing calculator. Go through the steps. If you're like, I don't remember them, then you didn't write them down. Write them down when we go through them next time. Maybe your neighbor will remember them right now. All right, second calc, intersection. We're going with first curve, enter. Second curve, enter. Guess. We remove it as close to the bottom one. We get -2, -4. Yes. As in C. Yes. Okay. Good. So to recap, I'm not going to expect you to graph each of these by hand.
Oh,
I want you, when we're graphing them, I want you to get used to using that calculator. Now the problem is, if you don't have a graphing calculator, you're going to have to use Desmos online. Just go to online, type in Desmos. There's an online graphing calculator. Okay, or if you put it on your Android phone, if you have an Android phone, you can get the app for it. Okay? Huh? Yeah, there might be one for iPhone, but. All right. Hey, next piece. Take a look at number 7. We're going to use substitution. Tell your neighbor how to substitute.
You put the equation into the other equation. There you go. We're done. Everyone explained that
Some
all
of you are like, I kind of remember the word substitution. We had a substitute last week. Okay?
So you put this equation over here.
It's true. Hey guys, substitution, right?
6.
You're putting, you know y equals 6, so when you see y in the top equation, you can put that in. That's substitution. So this top equation now is not y minus 2, it's 6 minus 2 equals x squared. So 6 minus 2 is 4, so 4 equals x squared, so what is x?
Square root of 4.
It's the square root of 4. What happens when you impose a square root? Plus, minus. So your answer is 2 and -2 for x. All that means is when you are finding your points of intersection, when you're finding your points of intersection, you're going to have a 2 in one of those and a negative 2 in the other. You still have to figure out what y is. Well, what is y? Yeah, it's 6. They tell you. In this one, it's easy. It's 6. They actually say y equals 6. It'll always equal 6. Right there. Now, please note that when you're graphing these, you can have a bunch of different situations. You have a parabola that gets crossed twice with a line. You could have a parabola. Can you guys make a parabola cross only once? Yeah, go ahead and do it on your paper. And then draw another parabola where it doesn't cross at all.
Wait.
Oh, we have these square roots now. In this stuff.
Crosses once like that. So that means one solution here, 2 solutions here, no solution right there. Okay, the line just doesn't hit it. Actually, in that case, there would be eventually, maybe. So let's do this. Now it does not hit it. No solution. I'm waiting. Right, the other way? Yeah, because the parabola expands, so it could have. It just depended on the slope of the line. Yeah. All right, let's try number 10. Everyone take a look at it. Number 10.
Yes.
Oh, hold on. We're about out of time.
Oh.
Time flies when you're having fun.
No.
Okay, your assignment is, hey, we'll pick up there tomorrow. Or Monday. Your assignment is page 1 or page 304. Finish that page. Okay. Good job today.